Alright guys, complex circuits. I'm not sure how much of this I'm going to be able to cram into this little board, but so complex circuits are not that complex. It's just that they have aspects of both series and parallel, and this is the thing. So I've drawn this complex circuit here, and I'm going to give some values to some of these guys. So R1 we will make 10 ohms. R2 will make 3 ohms. R3 will be 5 ohms. And then R4 will make 24 ohms. So those are all my resistors. And so, if you can tell, some aspects of this are series and some are parallel, right? These two are in series, but these two are in parallel with R4, and then all this stuff is in series with R1. And so you'd be asked to solve for various things on this circuit. So here we go. First thing I'm going to do, I know my total voltage. I'm going to try to find total resistance. And so what I do here is I think about this. I start the most complex part. I look here and I say, okay, these two, how are they wired? They're wired in series. Which means these two are acting like they are one resistor. And if I redrew my picture down here, there's R1, it would look like that. So these two are acting as if they are one. And so I can just add those two up. Okay? So that would be 2 and 3. So this total right here is 8. And those are acting as if they're 1. Okay? And then what happens really is you have these two that are in parallel. So these two are 8, and this one is 24. So to add those two up, they're in parallel. So to add those up, I got to do my parallel rules. 1 over 8 plus 1 over 24. And then I'd have to solve that. 1 over 8 plus 1 over 24. Take the reciprocal. So that gives me a total resistance of 6 ohms. So what we really have, these are acting as if they are one resistor that has 6 ohms. So our picture is really, and you guys may have to back this up and kind of watch it again. But here's what the actual picture is really going to look like. It looks like one resistor. All three of these are acting as if they are one that has 6 ohms. And it's in series with R1, and R1 is 10 ohms. And since those are in series, we just add them up, and so our total resistance, RT, is 16 ohms. Now, I like to say this in class. Batteries are dumb. They don't have a brain in their heads. They're dumb. The battery thinks it's connected to one resistor that has a total of this much. 16 ohms. That's it. Batteries don't know any better. You don't really have one. You actually have 1, 2, 3, 4. But it thinks there's just one. Now, using this, we can find our total current using Ohm's law. IT equals VT over RT. VT was, for my last example, VT is 48. RT is 16. Right? Three amps. So there you go. And look at all that work. It already looks really busy. Busy, 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 busy. All right, so hopefully you've watched that again and taken a look at it. We figured out that our total resistance was 16 ohms. Total current is 3 amps. So now you may be asked to find how much current is going through these, or what's the voltage drop, and that can take a little bit of work. So what we know here is that we have 3 amps coming out of our battery. I have 3 amps going this way. And all that amperage, all that current, maybe you think of it as water flowing through pipes. Well, however much water comes out, I got the same amount of water coming back in. So coming this way, I've got to have 3 amps. Which means coming out of the back end here, got to be 3 amps. Going through this guy is 3 amps. So how much current does this guy see? Well, it's 3 amps. Okay. Now using that, you can figure out what your voltage drop here is, right? So our voltage drop for R1, we're going to use Ohm's law, V equals IR. The I that this guy sees is 3. The R is 10. So our drop here is 30 volts. Okay. So what the heck does that mean? Well, that means that we started with 48 volts. If I put my voltmeter anywhere on this part of the circuit, it'll say 48. But then this guy takes 30. So after this point, we only have how much voltage left? 18 volts. This part right here, we had 48 volts. This guy took 30. We have 18 volts left. Make sense? It's the whole pizza thing. Watch my last video. Now, these are parallel branches. Each of those branches. Okay? Which means they get the same voltage. So each of these branches gets 18 volts. So, what would the drop be here? R4. Well, it's 18 volts. All the pizza gets eaten up. So what's the voltage on the very back end here? We put our voltmeter on the very back end. What's the voltage going to be? It's going to be 0 volts. Okay? So that's the thing. So now I can figure out how much current is coming through here. Okay? How do I figure out how much current's going through there? Well, I equals V over R. That's Ohm's law. What's the voltage here? It's 18 volts. What's my R? It's R4. It's 24. Right? That's 0.75 amps. That's how much current's going through there. Okay? Okay, so we had 3 amps of current. We still got to have 3 amps of current coming back. We had 48 volts. This guy took 30 volts, which means that's only 18 left. These are parallel branches, so each branch gets 18 volts. I used Ohm's law to figure out what the current was in this little branch, because I knew that there's an 18 volt drop and R4 is 24, so I got 0.75 amps. Look, R4 is 24 ohms. It's much bigger than either one of these. What's our total ohms here? Well, it's 3 plus 5, right? It's this one plus that one. So there's only 8 ohms here. So you could think of it as you have more resistance here. You have less at the top. You got to have 3 amps coming out, right? Current's going to go all the way back through. So I got to have 3 amps coming out. So if I have 0.75 down here, then that means how much current do I have at the top? It's 2.25 amps. Those are just ratios. You can just figure that out 24 ohms versus 8 ohms, you know, that's a 2/3, 1/3 thing. Whew! That's a lot of work. I may post, I think I'm going to post a little practice problem for y'all and you can fiddle with it. I may post this one and you can try it. Hope that makes sense. Ask me in a Zoom meeting.